All right, hello everybody. Welcome to week two, or I guess I should say the end of week two, the beginning of week three for FRC 2025 REEFSCAPE. This is Mr. Steele, the lead mentor for FRC 9062 Critical Circuits, and we have been hard at work this week finishing up our CAD, which is public on our Chief Delphi thread, as well as working on some 3D printing. So I'm going to go through today for the first few minutes and talk about different things we're working on. We are also working in the other rooms on wiring and partnerships related stuff. So throughout the day, I'll probably be coming back in and telling you a little bit more about what we're working on. So if you have any questions, please put them in chat. Happy to answer whatever and whenever. And I guess we'll get the show on the road. So one of the main things that we posted about yesterday that we saw some success with online, people wanted to learn more, were these, our 3D printed drag chain or energy chain pieces. We found these off of a German engineering website, downloaded them, changed the STL files so that they worked with our PLA printer. And then we also generated two end cap pieces that allow us to mount rigidly to some 2x1. And I'll show you the adapter in a minute. But we're really pleased with how these turned out. I'll see about posting this public if we can. I think one of our mentors has the file still, the raw file that we used. Because, I mean, a 3MF file is only helpful if you've got this model printer. In other news, we've been 3D printing gears and swerve plates. I posted about it today, so hopefully you guys have seen. In the background are some printers. They're doing the first few layers of two new prints. And I'll show you guys what we're working on with the black filament one, which is on camera right, I should say. And over here, we've got this really nice PLA swerve cover. Printing two pieces. We haven't started printing the second piece yet. This part is one piece, and this is the bottom layer. And I don't know if you can catch that on camera, but the quality is just incredible with this new, I don't even know what to call it, this new modified PEI plate. It's like a version 2 or something with a Teflon coating from bamboo. Can't say enough great things about it. There's also some 1032 socketed cap screw cover pieces there and room to access the encoder without having to take off the cover, which we really like. There's also two more tabs here and two more tabs here that we're planning on using to connect to our second piece that we're going to cover the actual gearing with. So this protects the wires in the encoder, and then we'll have another piece here to protect the gearing and the motors. Here's the connecting rod that Gabriella, one of our grade 10s, designed. So the idea is that we can put some 1032s through here, some 1032s through here onto the carriage of the elevator, and then no matter how high the carriage gets, we have a strong, rigid connection to our end pieces of our drag chain, which is awesome. Okay, Martin says he's coming now. Awesome. We've got somebody in chat who's actually walking to school today. That's nice. Another thing that we wanted was some 36 to 20 DP gears, and we found this awesome CAD file from West Coast. However, when we went to go print it, we realized that with no brim, no supports, the bottom looks significantly uglier. It ends up looking like this. And I don't know about you, I love macaroni and cheese, but I don't want it on the robot. So top turned out great, bottom turned out bad. We realized that it was because there's a 1/16 of an inch standoff on each side, or I should say like a boss built into the hex shaft. So we removed that in the CAD file, and it turns out awesome. We'll be posting this as well so that people can download this and use it without having to know anything about CAD in case you're using the Hatcher style intake that we've prototyped over the last 2 weeks. The intent of this is that everything's open source so that by the end of our 6-week build season, you'll be able to modify your robot to fit with any of our ideas if the strategy suits. Hopefully our strategy is good. Maybe it's not. We're going to learn all together whether this is a good robot or not. But the students here are absolutely incredible. They've been working tirelessly. They've been pulling long hours. They've been volunteering their time to make this robot the best robot we've ever produced. I am 100% proud of these students. I'm 100% dedicated to making sure that their vision gets completed, and I'm going to stay here as long as possible to make sure that we can get it done on time. So anyways, these gears are going to be used in our intake. They're going to counter rotate along with some compliant wheels, and this will allow us to sort of hatch panel it like 2019, intake the coral. The coral is a 4-inch ID PVC tube, modified PVC tube. Dropping stuff now. It's been a long day. So yeah, we're really looking forward to this 3D printed gear system working while we are on standby and ordering some more gears from, I believe, Andy Mark, if not Studica, to avoid some tariffs. So I think, considering this was the original, a 36-tooth aluminum gear from Vex, and then we turned it into a 36-tooth printed gear from West Coast with that ugly spaghettifying on the bottom, and then version 3 has completely PLA piece. I'm pretty happy with that. We're reducing the weight, we're also reducing the complexity, and we're easing ourselves into a world where we can have modifiable spacers on the edges. As for other updates, we're currently working on power and CAN bus and accessing the elevator, adding the elevator onto our practice drivetrain. We're fortunate enough to have 8 swerve modules right now. So this allows us to have 2 robots going at the same time. It's been awesome. We've been driving it around while we're also building it. I've never had that happen before. So I'm just going to go and check in, see how the students are doing, and enjoy this sort of idle ASMR as we've got the brand new air filter over there and the 2 bamboos. And if anyone has any questions, put them in chat. I'm happy to answer them. Enjoy. Oh yeah, one other thing I'm working on right now in the other room, the P1S is printing the beginnings of our new climb mechanism. We're going to print it completely out of PLA rather than sending it out for manufacturing to double check that the geometry works. We are modifying the EveryBot climber from the 2025 FRC EveryBot. Special thank you to Team 118, the Robonauts, for putting that together, as well as Team 10,118. More Robonauts, I suppose. Hello again. So to the 4 people watching, thank you very much for watching. Appreciate it. We've been documenting our process as we are Open Alliance, fully open source, fully just streaming, unedited, so that you guys can see our workflow, our process, our successes and our failures. And with failure comes lessons learned. So one of those failures was our intake designed to fit 2 sets of 2-inch rollers. The issue with these rollers is that they conformed, or rather complied, to the shape of the algae, because the algae is such a large game piece. We were trying to impart like 3 inches of squish onto it. And with the 30A version of these wheels, they squished way too much. So we switched to like 45, 50, 60A, and they worked fine. The other issue is that we wanted to get a little bit more grip on it. And when it doesn't comply, the grip on these is not fantastic. So we ended up getting some extra special wheels custom made for us from Team 3161. So this is a custom urethane wheel, 40A durometer, and it is the single greatest algae intake wheel I have ever tested. And we've tested like 100 different wheels to see which one's the best. It does not comply as much, but if you'll notice, the side profile allows for a higher surface area. So when I squish both of them equally, it conforms very little, but it has the same effective diameter as a 2-inch 50A wheel. This means that we can get the same amount of torque, better grip, and less variance in how squishy the wheels are actually going to be. We're also hoping this will increase the amount of inertia that we can have in the wheels to potentially yeet it into the upper barge. Oh, hey, Gerald is in the chat. Hey, Gerald. Nice to see you. Hope you're having a nice day. Thanks for your help last weekend. Really appreciate it. And I think the other print on the P1S just finished, so I'm going to go take a look. So all the blue stuff and all the paper covered stuff is not impacting something. That happens. But I can also order some more real quick off Amazon. Send me the link to whatever you want. No, because of these. Yeah. Like, look at those two places. That looks nice. Yeah, but functionality. Yeah, functionality over anything else, which is why I told them not to put the numbers on this first, because that makes it complicated. Gerald CM, no problem. Hoping to be able to stop by more often soon. Awesome, glad to hear it. So our PLA printer over in the other room, the P1S, just finished printing this piece here. And for those of you building an EveryBot, this might look pretty familiar. This is the functional and moving part of our climb mech. We're planning on modifying this in order to fit with the space constraints of our robot. So we're changing the hinge point, moving the hinge point a little bit closer to the bumper outer frame perimeter. And then we're also changing it from, I believe it was originally just a piano hinge. We're now upgrading it to 200-pound rated bushings. So that should allow us to take quite a lot of force on the support arm, as well as we're upgrading to a Kraken with a 75-to-1. I think it was 75-to-1 last time I checked the CAD for the winch. So it should be significantly stronger, stay up significantly longer, and just be overall a lot more rugged than the one that they had. Because we have those materials in-house, we might as well make use of them in season. I'm going to queue up another print behind me. This time it's going to be for the plate with the hex-shaped hole in it, and then we can do a fit test, after which I'll probably cut these out of polycarbonate by hand and sand them down to approximately the right shape. Oh, hey, Pretzel. Welcome back. Hope 9580 is doing well. So when you import a file like this, which was designed by 118, they designed from the front forward, not from the top up. We usually design from the top up, so all of our stuff prints automatically in the right config, but I don't know if you can see it on the screen. It's currently tilted up at 90 degrees. So you want to make sure that you have all your parts laying flat, otherwise that's a ton of material wasted. So let's see how long it's going to take us to print this on a P1S. This print will set us back 2 hours, 5 minutes. What if we go with a slightly lower quality? Because I really only need this in order to check dimensions. There we go, 57 minutes. That is spectacular. Yeah, we'd be prototyping our coral intake. Okay, so Pretzel, you got to tell me more about this coral intake. Is it similar or dissimilar to the ones that we've been prototyping? And is there anything that you want from us information-wise to help you design your coral intake? I know that when you guys were here, we were using plates like this. The only flaw being that this outer radius here is 1 inch, meaning that it's a 2-inch diameter, meaning it's the same diameter as the wheels that we were trying to put on. So we figured that out. Hopefully you're not having that issue. But if you're curious about like gear ratios, torque, stuff like that, I can help you out. I could even use AMB calculator to perform some calculations for you. Similar, can pick up both directions though. Okay, so is that like the 360 intake that we were prototyping with those 4 max planetary 90-degree gearboxes? Because it was heavy, but it was like robust, beefy, and efficient. Yeah, so the intake we make is similar to the first idea, but we made it so we can grab both guys from the coral station. Interesting. I mean, it worked out well for us. We just didn't go with it because it weighed like 6 pounds in our prototype. And we knew that it would weigh even more if we had to make it more rigid. So that's really the only reason why we didn't go with a pass-through intake. That and the reliability of sensors in order to have a soft stop rather than a hard stop. With our current design, we're planning on having both a hard stop and a soft spot in the same location for sort of like a dual identification, like a double check. And with any luck, it should fix most of our problems when it comes to intaking. Because I know in 2024, our first competition, we didn't have a proper beam brake. We had to rely on the current sense. And current sense is not very available on Kraken. Now that we don't need these plates, I'm planning on recycling them. This is a future project for TDJ20 students who go to CIC, that is Grade 10 Tech Design Open. They're going to build a 3D print shredder made out of actual steel parts, and then we're going to hand shred all these in little bits and form something new. So if you've got any advice, if anyone in chat has done this before, please let me know. Happy to learn more. It's sort of a pie in the sky idea of recycling filament, either new filament or into like sheet PLA. Either one would be sick. Like for example, this spaghetti gear, we don't need the spaghetti gear anymore. So it's going in the bin. This guy, however, I'm going to go trace in the other room. I'll be back in a few.
No. Why is it sunny your cup? I need to export. have to add this. What? Now,
What?
now it's just one.
I don't know. Where did it go? Okay, I thought this was inside. What? We only have one school back.
Report.
The school cover.
So 3 in black and 1 in white. Or just the side. The side of the school.
4 top in black, 4 white in
Looks so bad.
Bro, we only have one school. I don't know.
It's fine. The one that is coming is black. Like the one is shipping up black.
We order yet.
No, but
It's good to basically know. Set up.
that will mess a lot of things up. What is it set to? Do you believe on
Bro, we only have one school black. Oh, do some Google search.
Right, there's like 2 or 3 people in there, and we tell them about this, and then.
All right, guys. So I was just in there making a bunch of noise. We took this PLA print with like 30% infill, and then we traced out 2 acrylic versions. Don't use acrylic on your actual robot. Use polycarb, but this is the only quarter stock that I had close to me. So I figured I would try this out on this material and see how it works and report back. We're going to stop the live stream now because we've got a few other things that we need to attend to, and none of them happen in this room. So we'll see you guys tomorrow.